Welcome to Unit 4, Analytical Trigonometry. In this video, we are going to tackle an absolutely disgusting, look at my face, it's disgusting, simplifying trigonometric expressions. Listen, most kids hate this, but listen, here's why they hate it. They hate it because they don't like fractions. Boo-hoo. They hate it because they don't like adding fractions or subtracting fractions or factoring or simplifying or reducing fractions. That's why. So come on, get over it. Figure out basic algebra, and this lesson is actually not disgusting. It's not boo-hoo gross. It's actually quite easy. I truly, truly believe that. All right, so what the heck is simplifying? So simplifying is using algebraic techniques such as factoring, combining fractions over common denominator, distribution, or just reducing fractions to make an expressions easier and simpler to use. That's what simplifying is. Taking an expression, no equal signs here, ladies and gentlemen, no equal signs, just expressions, and making it easier, making it simpler, making it prettier. We prefer one trig function, sine, cosine, tangent. We prefer no denominator, but even if there's a denominator, it's not the end of the world, but we prefer no denominator. That makes things nicer. So listen, in some cases, simplification can be very dramatic. And what I mean by that is you might see an expression that makes you want to vomit. It is disgusting. It's got multiple trig functions. It's got fractions. It's got addition. It's got subtraction. And we could, it's insane. I know you're not going to believe me, but we could use the trigonomic identities to make an ugly, very crappy looking expression very, very simple. And I know it might be hard to believe me, but we just got to get through it. All right, here's the other thing. There's no rules. What? No rules? Well, okay, there's rules. We got to follow the rules of algebra. But there's no thing, I can't say, do this, A, B, C, and you'll get every problem right. Do this, 1, 2, 3, and you'll get every problem right. It's just not possible. So what we have to do is give you hints. We have to give you strategies, and it's on you to take those strategies to learn how to simplify. All right, so here are some hints. If you see a trig function squared, look to somehow utilize the Pythagorean identities. If you look at the Pythagorean identities down here with the yellow star, all of them involve squares. None of the other identities involve squares. So if you see squares, then I would definitely say, hey, how can I somehow, some way incorporate those Pythagorean identities? Factoring with trig functions is much like regular factoring and very important. So we got to be able to factor. Like if you see two terms that both have a tangent, hey, factor out that tangent. Just like if you saw two terms that both involve a y, you can factor out that y. So you got to be able to factor. And another thing is if all else fails, if you're just staring at a problem and you have no idea where to start, try turning everything into sines and cosines and see what happens. Now you might be like, well, what? Turn everything into sines and cosines? Yep. Look at the reciprocal identities. Cosecant can be turned into 1 over sine. Secant can be turned into 1 over cosine. Tangent can be turned into sine over cosine. Cotangent can be turned into cosine over sine. So you have 6 identities, and all 6 of them can be written in terms of just sine and cosine. Sine is obviously sine. Cosine is obviously cosine. Cosecant's 1 over sine. Secant is 1 over cosine. Tangent sine over cosine, and cotangent's cosine over sine. So yeah, sometimes just turning everything into sines and cosines can actually make it simpler because you'll see some things reduce. Now, the other thing you have to be able to do is be able to add and subtract fractions with trig functions. And if you can't add and subtract fractions as it is, well, then you're probably going to really struggle with adding and subtracting fractions with trig functions, but you got to be able to do it. If an expression says, hey, add these two things together or subtract them, my recommendation would be to do it, add or subtract them. Now, a couple more notes here. These simplifying problems are all over the place. Some are extremely easy, some are extremely hard. And a problem might be very easy to one person, but to another person that same exact problem is very hard, or vice versa for another problem, right? So it's all about the eyes of the beholder. You might see a problem as easy, others might look at it as very difficult. It all depends. It's just not possible for me to teach you one way that works for all problems. I'm sorry. You just have to try these. And at this point, you're probably like, I can't wait. This sounds super fun. I can't wait to get started. Oh yeah, it's going to be super fun. But you got to understand, there's nothing I can do that's going to say, hey, do this and it'll always work. You just have to use your brain. You may run into a dead end. So start over, do something else. Don't panic. If you do a bunch of work and it gets you nowhere, well, then just start over. Now, the other thing that a lot of kids say is, how do I know I even got to the end? If I hit a dead end, how do I know that that is not the end, the solution? Well, again, we want to simplify. So if it doesn't look simpler, you're not at the end. Trust me on that. So the only way to get better at these problems is to experience more problems. So I'm going to do a ton of these problems in this video. So yeah, strap in for a wild ride. But you also need to do a ton of problems on your own, because I'm not just going to give you 10 problems and give you the same 10 problems on homework. That would be pointless. You need to be able to use the strategies and skills I'm about to teach you to apply them to new problems on your own. So let's just get right down to it. All right, here is an easy one. Secant squared minus 1. Simplified. Now, to me, that looks pretty simple, but can it be more simplified? Well, let's go to do what I told you. I said, if you see a square, go to those Pythagorean identities. So where do I see a secant squared? I see a secant squared right here. But wait a minute. Right? Identities are equations. You are allowed to manipulate these, move things from one side to the other. So if I take this one and subtract it over here, I get tangent squared of theta equals secant squared of theta minus 1. It's just another way of stating this exact same identity. So guess what? What is secant squared minus 1? That was my original problem. Bingo. Tangent squared of theta. Done. I actually don't need to show any work. I mean, there is no work to be seen as long as you understand where I got that from. It was just, you could do this in your head. If you mentally see, oh, just take the Pythagorean theorem, subtract 1, secant squared minus 1 equals tangent squared. Oh my gosh, secant squared minus 1 is tangent squared. I'm done. All right, here's another one. Tangent squared x divided by secant squared. Oh boy, what do I do? I don't know. I mean, I see squares. So I guess I can go to the Pythagorean identities. Okay, well, check this out. Wait a minute, right? Tangent squared, we just talked about this, is secant squared minus 1. So I can replace this tangent squared up top here, because remember, you're allowed to replace. That's the whole point of identities. I'm going to replace tangent squared with 1 minus secant squared of x divided by secant squared of x. Then I could just use the rule of division, right? If you have 2 terms divided by 1 term, you could just separate that. That's 1 divided by secant squared minus secant squared divided by secant squared. It's actually like reverse combining fractions. I'm just separating it. 1 divided by secant minus secant squared divided by secant squared. Okay, well, this one's easy. Secant squared divided by secant squared is just 1. And 1 over secant. Oh, wait a minute. 1 over secant is cosine. That's a reciprocal identity. 1 over secant right here is cosine. Therefore, 1 over secant squared is cosine squared. So now I got cosine squared minus 1, and that looks pretty simple, but I can even do you one better. Look at the original Pythagorean identity right here. If I, listen, you got to really follow me here on this. If I subtract the 1 over and then subtract the sine squared over. So I'm going to bring the 1 to this side by subtracting 1. I'm going to bring the sine squared to this side by subtracting. Again, see that in your brain. Understanding that in your brain. That's going to be cosine squared minus 1 equals negative sine squared. So what's cosine squared minus 1? Negative sine squared of x. And there is your much simpler answer. Pretty easy. Okay, but of course, I just realized I made a mistake. Hopefully you saw it, and I need to redo this one. I'm very sorry. Can't believe I did it. Wish I could go back and re-record it, but I'm not. Here's the deal. I messed this up. Tangent squared is not 1 minus secant squared. It's secant squared minus 1. It's the same problem we just did right here. I just had a brain fart. Sorry. Tangent squared is secant squared minus 1. So I actually have to reverse this. It's going to be secant squared of x minus 1 over secant squared minus 1. Oh my gosh. Now I'm just compounding my mistake with more mistakes. Over secant squared of x. And then again, I'm going to separate this with division. So that's going to be secant squared of x over secant squared of x minus 1 over secant squared of x. Secant squared over secant squared is 1. 1 over secant squared is cosine squared. Again, that's the reciprocal identity. And then again, 1 minus cosine squared, go back here. 1 take away, if I subtract the cosine squared over, 1 minus cosine squared equals positive sine squared. So I had this one backwards, I'm sorry. So positive sine squared. So there is my final, more simpler answer. Now, wait a minute. As always, for a lot of these problems, there could be more than one way. Let's do the same problem another way. And maybe you like this way better. I'm going to actually use the quotient identities. So tangent squared could be looked at as sine squared over cosine squared, right? Tangent, by using the quotient identity, tangent is sine over cosine. Therefore, tangent squared is sine squared over cosine squared. Using the reciprocal identity, secant is 1 over cosine. So secant squared would be 1 over cosine squared. And again, this was another strategy I told you where you could turn everything into sines and cosines, and sometimes that helps. That's actually going to make this problem so simple. Now, I hate double fractions. You guys all know that. So if I take the numerator, you always leave the numerator alone, and I multiply by the reciprocal of the denominator. The reciprocal of the denominator is cosine squared of x over 1. Look what happens. Cosine squareds cancel. They reduce out. And I get just sine squared. Done. Easy. Move on. All right, here's another one. Oh, wait a minute. As soon as I see an x that's negative, I'm going to go right to those even-odd identities, right? So again, look at the problem. Cosecant of negative x, that's right here. Cosecant of negative x equals negative cosecant of x. So that's the first thing I'm going to do is I'm going to say this is sine of x times negative cosecant of x, right? That's using one of those even-odd identities. Now, again, I have multiplication. Multiplication you can do in any order you want. So I'm actually going to move this negative sign out in front. So that's negative sine of x times cosecant of x. And you may say, well, wait a minute, you said it's negative, not negative sine. Yeah, it's multiplication, guys. It's a -1. I put it anywhere I want. All right, and then, but wait a minute. Check this out. I'm going to use a reciprocal identity. Cosecant is 1 over sine of x. Therefore, the sine of x over sine of x is 1. So the only thing left is -1. There's my final answer, -1. No more trig at all. Talk about a simpler answer. Doesn't get much more simpler than that. Really, really easy. All right, here's another one, and this one is going to involve factoring. So I see a cube. I don't like cubes. None of my identities involve cubes. But wait a minute. Anything, terms are anything separated by a minus or plus sign. So when you have a plus sign right here, I have 2 terms, the one on the left, the one on the right. Both of those terms have a sign. So I can actually factor out a sign, and I get sine squared plus cosine squared, right? If you don't believe me, just distribute. Sine times sine squared is the sine cubed. Sine times cosine squared is the sine cosine squared. So again, I'm factoring. Both terms had a sign that I can factor out. The first term is left with the sine squared. The second term, the sine, is gone, so it's just cosine squared. But wait a minute, check this out. This is staring at you in the face. Pythagorean identity, sine squared plus cosine squared is just 1. Sine times 1 is just sine. So believe it or not, this problem that looked pretty ugly is just sine. So look at that. One step is all it took me, and what a dramatic change from something pretty ugly to something so simple. Hence, simplifying. All right, here's another one, and you're going to love this one. Again, anytime you see a square, jump to the Pythagorean identities, right? Especially when there's a 1 involved, because all the Pythagorean identities involve a 1 in squares. So right now I see 1 minus cosine squared in my problem. So I'm visualizing if I subtract the cosine squared over, 1 minus cosine squared is sine squared. So I can replace the entire numerator with sine squared. And then I get sine squared over sine. Well, wait a minute. That's sine times sine over sine. One of the signs cancels, and I'm left with just sine. Now, there's always multiple ways to do a problem. Another way you can do this problem is this. Check this out. You could just divide, right? That would be 1 divided by sine minus cosine squared divided by sine. Okay, now at this point, you're thinking, really, is that really easier? Does it really look easier to me? Well, it's not easier than this. I mean, this right over here is really easy, but it will work. All right, so let's see. Let's keep going. 1 over sine. Now check this out. I can actually separate this, right? On top is a cosine times cosine. So this right here is a cotangent. So I have 1 over sine minus cotangent of theta times cosine of theta, right? So again, the cosine over sine, again, it's cosine squared is cosine times cosine. So I could just take one of those cosines with the sine and get a cotangent. Okay, I'm slowly getting somewhere. I'm not really getting anywhere fast. It's obviously not as easy as my work over there in the orange, but I'm slowly getting somewhere. 1 over sine is cosecant. That's, again, reciprocal identity. So you're now looking at this and you're saying, is this any easier? Well, to me, that's a dead end, right? Like I tried something else. I tried a different strategy, just dividing 1 divided by sine minus sine squared divided by sine. And I was working and I was doing some good math and I was using the identities, but I got somewhere that doesn't seem simpler to me. That's what I was talking about earlier when I mentioned sometimes you get to a dead end. So again, think. Try different things. But again, when you see a 1 and a square, boy, use those identities, especially the Pythagorean ones. All right, here we go. Secant plus 1 times secant minus 1, all divided by sine squared. What do I do here? Well, lots of different things you could do. But again, when you see two parentheses butted up next to each other, that typically means to multiply. So why don't we multiply? So let's go ahead and FOIL. Secant times secant is secant squared. Secant times 1, a negative 1, is negative secant. On the inside, 1 times secant is positive secant. Ooh, I'm going to like that in a minute. And then 1 times negative 1 is negative 1, divided by sine squared of x. Now, what's going to happen really nice is that a negative secant and a positive secant make a 0, so they're gone. So I get secant squared of x minus 1 divided by sine squared of x. And now I'm thinking, wait a minute. Secant squared minus 1. That's a square and a 1. Ooh, check this out. Secant squared, if I subtract the 1 over, we've actually done this twice already, secant squared minus 1 is tangent squared. So I can replace the entire numerator with just tangent squared. And you say, okay, well, now where am I? Well, I'm still not anywhere yet. I'm going to have to move over here because I'm running out of room. All right, well, here I go. Well, let's, again, if you're ever just completely stuck, a big strategy is just turn everything to sines and cosines. Tangent squared, quotient rule. Tangent is sine over cosine. But again, it's squared, so it's sine squared over cosine squared, all divided by sine squared. Okay, I'm slowly getting somewhere. Trust me on this. All right, so the numerator always stays the same. I hate double fractions. Anytime you got double fractions, you should always get rid of them. How do you get rid of them? Leave the numerator alone. Multiply by the reciprocal of the denominator, 1 over sine squared. Aha! Sine squareds cancel. I get 1 over cosine squared, which is pretty simple, but it's still a fraction. But wait a minute. Reciprocal identities. 1 over cosine is secant. So 1 over cosine squared would be secant squared. There is a beautiful, beautiful, beautiful final answer. How about that? Really, really simple. Now, you might not think it's simple because you're learning this for the first time. I get it. But all I'm trying to do is throw as many different problems at you as possible. That way you can see a bunch of examples. All right, here is one of my all-time favorites. I love the math. I love the algebra in this problem, even though you're probably not, but I love it. All right, so again, number 1 strategy is look for squares and 1s. I don't see any squares. I see a 1, but it's not with the sine squared. I wish that was 1 minus sine squared, but it's not. It's 1 minus sine. And sorry, the Pythagorean theorem, the Pythagorean identities only work with squares. So what do I do? Oh, the second strategy is change everything to sines and cosines. Oh, well, that's already done for me. Well, you know what? Sometimes you just got to do what the problem says. The problem says to subtract. So let's go and subtract. All right, to subtract, I need to get a common denominator because you can't subtract 2 fractions without a common denominator. The easiest way to get a common denominator is just to take the 2 denominators you have and multiply them together. So I get 1 minus sine times cosine. Now, I know I can distribute that cosine, but I'm actually going to prefer not to, just to kind of understand so I can visualize and see the common denominator. All right, so this fraction right here has the 1 minus sign. What he needs is the cosine. That's no problem. As long as I multiply both the numerator and the denominator by cosine, I get the common denominator. So the numerator is going to be a cosine squared, because cosine times cosine is cosine squared. Minus. All right, this denominator, or this fraction, has the cosine. He needs the 1 minus sign. So I'll multiply numerator and denominator by 1 minus sine of x to get that common denominator. Now be careful, follow my directions here. I'm going to have to distribute because this is a negative sign. Negative sign times 1 is negative sine of x. Negative sign times negative sign is a positive sine squared. Hope everybody sees that. Again, I'm distributing. I didn't have to do that over here because it was just cosine times cosine. That's cosine squared. But since there was a 1 minus sign, I have to distribute the negative sign across. Okay, now, right, check this out. I got a cosine squared and I got a sine squared. So again, you could rewrite the order of that. That's going to be cosine squared of x plus sine squared of x minus sine of x. You could change the order as long as everybody maintains their sign. The sine is still negative. The sine squared and the cosine squared are both positive. All divided by 1 minus sine of x over cosine of x, or times cosine of x. But check this out. Cosine squared plus sine squared is 1. That is one of the easiest identities to recognize. So I'm literally replacing all of the cosine squared plus sine squared with just a perfect 1. So now I have 1 minus sine of x over 1 minus sine of x times cosine of x. And wait a minute, there's a 1 minus sine of x on top, and there's a 1 minus sine of x on the bottom. They're going to cancel. They're going to reduce their 1, right? A number over itself is just 1. So all that's left is 1 over cosine of x, which of course I'm going to make secant because of the reciprocal identities. Talk about a dramatic change. Like, this is like one of those, HGTV home makeover shows. I mean, I went from this ugly fraction, and I reduced it. I simplified it using the identities to nothing other than just a single secant. That is awesome. All right, let's try this one on for size. Okay, don't see any squares. Okay. Well, that next strategy that I talked about quite often is just changing everything to sines and cosines. It's really a great strategy. All right, so we have sine of theta. Or, you know what? Okay, I take that back. I'm going to do that. But a lot of kids will say, oh, let's distribute. And that's a great strategy, right? You see parentheses, you think distribute. So let's go and do that. Sine times cosecant is, well, sine times cosecant. Okay. Minus, okay, now I'm going to have 3 terms. I got sine times cosine times tangent. Okay, got a lot going on there. Sine times cosine times tangent. Okay, great. All right, but let's do that next thing I was mentioning where you just say, hey, I don't know what else to do. Let's just turn everything to sines and cosines and really just kind of hope for the best. So sine is sine. Cosecant is 1 over sine. Ooh, that's going to be nice. Very nice. Okay, I'll handle that in a minute. Now over here I have sine times cosine times tangent, which quotient rule, quotient identity, sine over cosine. Whoa, okay, hold on. I'm seeing something here. All right, so let's just go. I'm getting really excited. So let's just go step by step. Sine over sine, that's 1. They don't cancel, they reduce to a 1. A number over itself is 1. So sine over sine is 1. Minus, all right, now here, the cosines are going to cancel or reduce to a 1. Cosine over cosine is 1. And I'm left with sine times sine, which is sine squared. But don't stop there. Now I see my square. I see my 1. That immediately takes my attention. Anytime I see squares and 1s in the same area, I go right to those Pythagorean identities. So again, what am I seeing? Well, this time if I subtract the sine squared over, so I get cosine squared equals 1 minus the sine squared. So 1 minus sine squared is cosine squared. There's my final answer. Done. Easy. Walked away. Simplified. All right, let's check this one out. Ooh, okay. Right away, right? First instinct, I see squares. Anytime I see squares, my first thought is at least look at the Pythagorean identities. Now check this out, check this out, check this out. Secant squared minus tangent squared. Let's do a bit of manipulating. If I take the secant squared and I subtract the tangent squared to the other side, I get 1 equals secant squared minus tangent squared. Again, you have to be able to visualize that. Take the tangent squared, subtract it over. You get secant squared minus tangent squared equals 1. So, ladies and gentlemen, that numerator is 1. And then you say, well, wait a minute. That's a reciprocal identity. 1 over cosecant is just sine. One step. I guess 2 steps. Oh my gosh. Come on. These are not that hard. That's my goal is to try to convince you of that. But you got to really work through these. All right, just a couple more left here. All right, no squares. Yeah. Can't use Pythagorean identities right now. I don't know what else to do. Again, it says minus, but I don't even have any denominators to try to combine them. So again, this is another one where maybe the best thing is just to get everything in terms of sines and cosines. So secant is 1 over cosine of theta. Cosecant is 1 over sine of theta. Okay. Tangent is sine over cosine. All right, so this is one fraction. It's 1 times 1 is 1. Remember, when you don't need common denominators to multiply. So 1 times 1 is 1. And on the denominator, I get cosine times sine. Okay, great. Over or minus sine of theta divided by cosine of theta. All right, now let's go ahead and get a common denominator. Right? How do you get a common denominator? Well, let's see here. My common denominator is just going to be cosine times sine. I mean, this guy already has that, and I could easily make this my common denominator as long as I multiply both by sine. As long as I multiply top and bottom by sine, then I don't need to make any adjustments to the first fraction, so that 1's going to stay there. And then the other fraction, to get that common denominator of cosine times sine, I have to multiply numerator and denominator by sine. So I get 1 minus sine squared of theta on top. And now I'm like unbelievably giddy because that's a Pythagorean identity we've seen several times now. Again, you got to visualize if I subtract this sine squared over, I get 1 minus sine squared equals cosine squared. So that numerator becomes cosine squared of theta all over cosine of theta times sine of theta. Now slow down here. Cosine squared is essentially cosine times cosine. So one of those cosines will cancel with this cosine on the bottom. So what's left is cosine of theta over sine of theta. Again, it was a cosine squared. It's just like x squared over x, right? X squared is x times x. So one of those x's will cancel with this x, and you just get x. So, but wait a minute. Oh my gosh, come on. You should recognize cosine over sine is cotangent. Look at that. Look how ugly this first problem was, and it made a dramatic change, right? It's literally just like those home makeover shows. They take this crappy house, and it's amazing when they're done with it. All right, 2 more to go here. All right, 1%. Oh, wait a minute. Square with a 1? Oh my gosh. Right here, let's literally stare at you in the face. 1 plus cotangent squared is cosecant squared. So right away, I'm going to replace all of this. I'm not going to distribute and waste my time. Again, that's what some kids will try, but listen, if you see a square and a 1, go for it. So that's going to be cosecant squared. Now notice this time I got an alpha. This is the first problem where I have a different variable. If you don't like drawing alphas, go back to theta. Go back to x's. I don't really care. I just like to mix it up a little bit just because I think it's fun. But anyway, my point is I don't care what variable you use as long as you're consistent. All right, so anyway, divided by cotangent theta. So now or cotangent alpha. There, I even said theta and I wrote alpha. So now I'm thinking, well, what do I do now? Oh, I don't, well, again, I don't know what to do. So sometimes when you're completely stuck, change everything to sines and cosines and kind of cross your fingers. Tangent is sine of alpha divided by cosine of alpha. Cosecant squared is 1 divided by sine squared of alpha. I almost wrote a theta, alpha. All divided by cotangent, and cotangent is cosine over sine. Okay, and right away I'm like, oh, I hate double fractions. So let's kind of take our time with this here, because I just hate these double fractions. So let's notice a couple things. The numerator, first off, the numerator, check this out. This sine will cancel with one of these signs. Kind of the same thing we just saw in the previous problem. Sine squared is sine times sine. So one of those sines will cancel with this sine because they're common factors. So my numerator is 1 divided by cosine of alpha times sine of alpha. Sorry for my messy handwriting. And then I hate double fractions. So instead of dividing by a fraction, let's multiply by the reciprocal, sine over cosine. All right. Oh, and then look what happens. The signs are going to reduce again to a 1. And all I'm left with is 1 over cosine squared of theta, which is a great answer, but why not use the reciprocal identities? 1 over cosine is secant, so 1 over cosine squared is secant squared. And look what I did. And this is something that I'm okay with. I wouldn't be mad if you did this. I went from writing alphas. I even talked about how I changed it to alpha, and then I just got so used to writing thetas that at the end of the problem it became a theta. Not the end of the world. Here's what I will take off for. I'll take points off if you just write secant squared. I hate it when kids do that. Where's the variable? You got to have a variable there. X, theta, alpha, beta, I don't care. You got to have a variable there. Or kids that just write tan, sine, cosine. You got to have a variable. I don't care if you use X or alpha. You got to have something there. But anyway, pretty ugly problem to start. And again, nice ending. All right, one more problem to go here. And this one's a really simple one. I'm just going to go ahead and divide, right? It says to divide. Let's divide. And again, you got to split that up. So that's tangent of beta divided by tangent of beta. Love that. Plus cotangent of beta divided by tangent of beta. Again, tangent of beta divided by tangent of beta is just 1. Plus, now again, what I'm going to do here is I'm going to change everything to sines and cosines. Cotangent is cosine of beta over sine of beta. All divided by tangent is sine of beta divided by cosine of beta. So that's 1 plus. Now, wait a minute. I hate double fractions. So, of course, let me just kind of come to the side. Of course, I'm going to take the numerator, leave the numerator alone. And I'm going to multiply it by the reciprocal. The reciprocal of that denominator is cosine of beta. There, I almost did it again. Over sine of beta. And that is, of course, going to be, well, look at this, right? That's going to be cosine squared over sine squared. Cosine squared. I did it again. I changed it to theta. Sorry, I just get so used to writing thetas. Doesn't matter, though. It's good to show. Cosine squared over sine squared. But wait a minute. Cosine squared over sine squared, that's cotangent squared. So I know I did a lot right there, but just kind of follow my logic. Tangent divided by tangent is the 1. Cotangent divided by tangent, well, that kind of took a little bit of time to reduce. But you know what? If you don't like what I did by turning everything sines and cosines, check this out right here. Go back here for 1 second, right? Just listen to me here. If you're smart, you'll understand this. Numerator always stays the same. Multiply it by the reciprocal of the denominator. What's the reciprocal of tangent? Cotangent. What's cotangent times cotangent? Cotangent squared. I mean, how simple is that, right? The idea is that I'm just saying, hey, I know what the reciprocal of tangent is, right? Yeah, the reciprocal of tangent's 1 over tangent. But guess what? Look at your identities. 1 over tangent is cotangent. So that's why I just turned the, and again, you know what? Here's another way of looking at this. Treat that as cotangent times 1 over tangent. And then you can literally see, oh, 1 over tangent's cotangent. So I got cotangent times cotangent, cotangent squared. But don't stop there, because anytime you see a 1 in a square, look right here. 1 plus cotangent is cosecant squared. Final answer, cosecant squared of theta. Actually, it should be cosecant squared of beta, but I'm not really a big stickler as long as you got a variable there. Listen, I know you're probably sitting at home right now or sitting in the classroom and you're like, whoa, that was a lot. That was scary. That was confusing. It is. Not going to lie. I'll literally never forget the first time I started this in high school. I cried. I remember going at home and crying to my dad because I couldn't do it. It was a struggle for me. But you know what? Here I am now. Yeah, I hope it doesn't take you 24 years to figure out. But obviously I figured it out a long time ago. I did figure it out. Even though I did want to go home and cry to my dad, I figured it out. You just have to have a little bit of gumption, right? You got to have a little bit of fight in you. You got to persevere. You got to understand sometimes you get to dead ends. And you got to understand if all else fails, change everything to sines and cosines. And as long as you do it correctly, you don't make any mistakes with that, it actually will usually work 9 times out of 10. All right, get ready to just try a bunch more of these because that's all we're going to be working on for the day. All right. See you guys. Enjoy. You probably didn't like this video. Sorry.